Yeah, thanks. So this is a side project that Isaac and I made when we were asking the question, how much can you compress embeddings and kind of do things with them? So we came up with two projects. Isaac will talk about his. DeltaBit is what I came up with. And what you're looking at here is a web application with a swipe map that shows Sentinel-2 2020 imagery over Seattle on the left, and then 2024 imagery on the right. And on a backend layer that's not being visualized, we're also serving 8 channel quantized alphabet or alpha Earth per pixel embeddings, where we take the 2024 alpha Earth embeddings, subtract the 2020 alpha Earth embeddings from them, and then take the top 8 principal components per pixel, and then kind of serve those directly to the browser as XYZ tiles, like you would do kind of any other layer. And that's small enough that you can do that interactively. So every time I scroll around the screen, we're loading 3 layers, the imagery from time one, imagery from time two, and those kind of back-end embeddings at the per pixel level. And what we want to do here is let people train a change detection model interactively in the browser. So I'm kind of swiping back and forth here with a hotkey, and you can see that there's a good bit of deforestation happening. We want to train a model that is able to detect this. So what you can do is click on this change and click, 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 click to say that those pixels are changed. And what I'm doing is like interactively making training data labels here. These pixels are all non-changed. And then when I hit train, there is a linear model that's being fit based on those labels that I just put down on the map. And then running on web GPU over that third layer of 8 dimensional kind of PCA embeddings per pixel, and we're showing the probability that each pixel is changed on the map. And you can do this fast enough to where it's completely interactive, and these are not like pre-computed results. They're being generated on the fly from overviews from the high res, like 10-meter data, just completely in browser. There's no backend whatsoever here. And if I see something like this, I'll change to just like a binary representation, maybe go back and forth. And I can see like over here, there's some change that's not being picked up on. And then I'll update that and say, hey, those are all changed, retrain, and then it cleaned up that layer a little bit. And that's basically it. You can do change detection really, really quickly in browser if you can get the per pixel embeddings to kind of the clients or the user's browser in a small enough way to be useful. And you can also do other types of change detection. So if I go into kind of an urban area here, let me refresh. And Max, feel free to cut me off if I'm over time. But I happen to know that there's been like construction here on this highway. This wouldn't be picked up if I was just training the model in kind of forced, non-forced change. But I'll mark a couple of things over here is not changed, train that, and now it's picking up kind of more urban changes instead of kind of deforestation events. Just to zoom in, what is this? Yeah, that's a true positive. Yeah, that's basically it. I'll put the link to the open source repo to this web app if you want to play with it. The open source repo lets you reproduce this for any new Sentinel-2 tile. So you can compute the backend, you can compute the tile layers, and it'll stand up an instance of this for you. Thank you so much.